And I'll show you a profile of this in a cross-section, but you see the difference in the types of accuracy and the resolution of the features that it can pick up. And looking at in cross-section, you can see the LiDAR data is showing that the peninsula downtown in Charleston was a lot lower than we initially thought with some of the national elevation data sets. We were up to up to 10 feet or 3 meters lower in some spots. So this is not good news for our low-lying cities. If we initially thought we were higher elevations, we're starting out kind of lower than we thought, and that just goes to show that these areas are definitely vulnerable to inundation. And this translates into a lot of inundation when you look at horizontal mapping of that change. And you can see here on the left-hand side, looking at 3-meter LiDAR-based DEM versus some of the sources of elevation data based on the national elevation data sets. The pink area here shows the uncertainty in some of those national data sets, whereas you have a much smaller area of uncertainty in the LiDAR-based data. Now, the national data sets are getting better all the time, and a lot of especially the NED, the LiDAR is being incorporated into the NED now at a 9th arcsecond product, which is much better. We're starting to get a lot more coverage, so it's not as much of an issue, but there still are places on the coast that we have to be careful, and we really can't use some of the worst quality data. So the first step in doing the mapping, any kind of flood mapping, is to build your terrain. And we go to national sources like the National Elevation Data Set. We go to something called Digital Coast, which I'll show